So functional pin diagram of 8086. So in the functional pin diagram, this is the IC. Okay, there are two types of IC. Let me write something over here. So there are two types of ICs. Okay, so here DIP type of a packaging. So this is called as a dual inline packaging. And in this packaging, the IC has pins on both sides. Okay, so in this packaging, IC has pins on both sides, and IC has one socket. Okay, so we need to fit the socket, and in that socket, we can fit the IC. Okay, so this is called as a DIP-IC, and there are another type of packaging called as a surface mount packaging. Okay, SMP. So SMP device this is a DIP packaging is a old technology, as 8086 is a old processor. It follows DIP type of packaging, and it has a pins on both side. And if there is something problem in the IC, you can replace the IC with the new one. Okay, but the DIP IC are a little bit more cost. We have to pay more cost because this is a old technology, and nowadays most of the IC manufactured are SMD mounting. Okay, so surface mounting will be there, and the pins of the ICs are soldered. Okay, so pins of the ICs are soldered, and we can't replace them. If the IC had some fault, then we have to replace all the board, and there is no possibility of replacing the IC. DIP packaging, in the DIP packaging, there is a possibility that if the IC has some damage, we can replace it. So this is the main difference. So here we have at both sides there are pins. So 20 pins at one side and 20 pins at other side. So here this is the first 20 pin set. This is the 20 pin set. So there are total we are having 40 pins of the IC, out of which few pins are used for maximum mode and minimum mode. Now in the minimum mode operation, 8086 has a single processor operation, that only 8086 will be available along with the few interfacing devices. And in the maximum mode, more ICs will be there, and one of the 8086 IC will act as a master and others will act as a slave processor, or they are followers. Okay, so maximum mode, the pins we are using for maximum mode as well as minimum mode. So first of all, we will look at the pins which are available for power supply. So first, this is a VCC pin, which will act as a power supply pin. So VCC, this is here we will provide plus 5-volt supply. Then VSS, there are two VSS pins are available. VSS pin number 1, VSS pin number 20. So these two pins are acting as a ground pin, or excess current will flow through these two pins, to avoid the damage of the IC. So these three pins are considered as the power supply related pins. Now another, as we know, 8086 is a 16-bit. Okay, 8086 is a 16-bit processor. Okay, so 8086 has a data bus of 16-bit, and 16-bit, and address bus is of size 20-bit. Okay, so we need total, if we have a separate pin for each function, there will be requirement of the pins. Okay, total pins required will be 20 plus 16, and so it is quite high. Okay, so to avoid this higher number of pins, what we have done, out of these 20 pins, 16. So what we have done, 16 pins plus 4 pins. Okay, so what we have done, 16 pins plus 4 pins. So out of these 16 pins are multiplexed. Okay, multiplex means pins are having dual functionality. Okay, so the address oblique data bus. Okay, so address oblique data bus means initial 16 pins. Okay, 16 pins acts as, okay, it's act as address pins in the initial phase when the address is issued and address is available on address bus, and once the location is accessed and there is no need of address anymore, then afterwards these same pin will act as these pins will act as data bus. Okay, so data bus, and then initially the on the address pin, initially the address will appear on the address pin. So the initially the address will appear on address pin, and afterward the data will appear on data pin. Okay, so so data will available on the data pin. So when the pin will act as a address or data. Okay, so first initially the pin will acting as a address, and after when the location is accessed, then it will turn into a data pin. So initially so here look at the pinout diagram. So let's understand here pin number 16, uh, so 2 to 16 on one side a, so we are having AD0, AD1 up to the AD14. So these are the multiplex address and data line. Same way as we explained, total 16 pins are acting as a multiplex, so that the pins has dual functionality. At the initial time, it will act as address, and afterward it will act as a data. So this is the, on the other side, pin number 39 act as a address and data line. So this is AD15. So we can say here AD0 to AD15. These pins are act as a multiplex address and data pins. So these act as a multiplex address oblique data. Okay, now the remaining pins. Okay, so these are the about the first 16 pins out of the address bus is of size 20. So remaining 4 pins. So the remaining 4 pins. So the remaining 4 pins. Okay, so which are the remaining 4 pins? So we are having here here we are having here the remaining 4 pins. Okay, so so these are 16, 17, 18 and 19. Okay, so these are the AD16, AD17, AD16, 17, then 18, then AD19. Okay, so these are the 4 remaining pins which are also multiplex as a status pins. Okay, so here see, here these are the pins. So first pins from pin number 2 to pin number 16, AD0 to AD14. So these are the first 14 pins. So the 14 means 15 pins. It's because we are counting from 0 to 14 means total 15 pins. This is AD15 means 16 pins. So total first 16 pins which are having only 2 functionalities. that it will act as an address, it will carry the address and it will carry the data. And as the data bus is of say 16 bit, so again, so our next address and data lines will not be used for the data transfer, and it will use only for the address purpose. So these are the remaining four pins: AD 16, 17, 18 and 19. But these pin will along with, again, as to reduce the number of pins required, again we multiplex these pins with the status pins. Okay, so here AD 16, 17, 18, 19. So these are the multiplex with the status pins S3, S4, S5, X6. In the next slide, I have included one table. Okay, so which will explain the functionality of the status pin. Okay, so which will explain the functionality of the status pin. So let's understand the next point. So I will clear this drawing. We'll go to the next slide. Now here, as I explained, VCC is the power supply pin. VSS, there are two VSS pins, 1 and 20, which act as a ground pin. Okay, so these are acting as a ground pin. So pin number 1 and 20, pin number 40 is acting as a VCC. AD0 to AD15 are multiplex address and data bus. Okay, the next line, that is the remaining pins S3, S4, these two pins. So first initial A16 and A17 are multiplexed with the S3 and S4. Okay, so S3 and S4. So when these two pins, now these two pins are used to indicate the status of the which segment is selected. As we know, there are four segments: code, data, stack and extra segment. Okay, so as according to the functionality, these four segments are used according to the memory reference. So if the instruction are accessed, then code segment will use. Then if the stack related information we need to save, then stack segment is used. Then data related information we are using DS and ES. So to select the different segments, we are having these two status pins. So if these two status pins are set, then the particular segment will be accessed. So this is related with S3 and S4. Then S5 will act as an interrupt flag. Okay, as right now we don't know the status of the how the interrupts are handled, but afterwards when we learn the status of the interrupts, then we can understand how the interrupts are used by 8086. So at that time we will use the this particular pin, that is S5 pin. Okay, and then S6 pin is using for master mode. Okay, status of bus master. As we know that 8086 can act in two modes: min mode and maximum mode. Okay, in the minimum mode, we can use a single processor with some peripheral devices, and in the maximum mode, more than one processors will we are using. And again, we need some bus controller function at the maximum mode. So at that time, when we are using bus master configuration, at that time S6 pin will be used. So this is related with the first address and data pins. Okay, now the next pins. So next pins are key. As we know, there are a higher bit address and lower bit address. Okay, so there are 88 bits are used. So you will write something related with this. So as we know, there are two 16-bit data. Okay, so we are having 16-bit data, and out of which a lower 8-bit and upper 8-bit. Okay, so this is higher higher 8-bit data and lower 8-bit data. As we know, okay, as we know that there are a few registers which are acting which are only which are using only the 8-bit data format. For example, AL, AH, AX, BX, CL, CH, like this way. So whenever there is a upper 8-bit is accessed, okay, when the upper 8-bit is accessed and when the lower 8-bit is accessed, that we need to identify, or we need to identify whether my data is of which size. Okay, my data is of 8-bit size, my data is of 16-bit size. At that time, this BHE, burst high enable, what is the long form of BHE? Burst high enable. And S7, okay, S7, this combinedly explains the status of the data. Okay, whether the data is of 16-bit size, whether the data is having the higher upper bit, okay, will be accessed or none. Okay, so like this way, BHE and S7 will combinedly explains about the status pins. Okay, so this is the next. This is related with the upper 7 bits. So status, all status bit I have explained. So here this is S0, S1. So I have explained here these line BHE, BHE, B7. So we have completed VSS, VCC, VSS. Okay, so there are two VSS pin which acting as a ground, one VCC which is acting as a supply, then AD0 to A15, 16 upper address lines. Then this is lower four address lines multiplex with status lines. Then data condition is explained by BHE or S7. Okay, now next pin is min or max mode. Now we need to understand that key first function and second function. When the high is we set the pin high, then it will be in the minimum mode, and when we set the pin as low, it will be in the maximum mode. Okay, so this is a min or max pin. Then read bar. Okay, read bar. So whenever the data is read by the 8086, then read bar is activated and it is active low. So dash, this is the slash, it means that it is the active low pin. Okay, now along with the read bar there will be one write bar also. Okay, now here the next pins are for the next pin we will look at the more explanation. Okay, now we have again I explain you the read bar, same thing is there for the write bar. Okay, whenever the data we have to write on the data lines, then the write bar will be activated. Okay, so this is related with the write bar. Now let's understand next, that is the next pin. So test pin, ready pin, these are used for the reset. Again, reset is the one functionality. Okay, so here reset. So the commonly used pin reset. All the time we know that whenever there is a so there we need to start a new program, all the time we have a button called as a reset to clear the previous program from the IC. Okay, so the reset is a very important pin function. Then the clock frequency, as we discussed previously, the clock is a bit supplied from 5 megahertz to 10 megahertz and 20 megahertz. So the clock frequency is given at the clock pin number 19. Interrupt is given at the pin number 18. Okay, so these are the functions of the pin. So now only these pins are remain. So we will discuss this pin afterward.